So it's my pleasure to introduce, to bring us home, the final keynote session of the day, Dr. Cathy Foley, coming to us from Australia. So Dr. Foley has quite the honored history. She's a fellow of the Australian Academy of Technological Science and Engineering, fellow of the Australian Institute of Physics. In 2020 became a member of the Australian Academy of Science, and just this past January took her role as Australia's 9th chief scientist. And so she's going to be talking to us today about what is happening in quantum in the land down under. And I wonder whether qubits are inverted there. Thank you.
Thanks very much, and hello everyone. It's great to be here. In Australia, we have the tradition of starting any of our presentations by acknowledging the many lands that we're all coming from today, especially in this international space. In Australia, I'm speaking on the traditional lands of the Camaragal people and pay my respects to elders past, present and emerging. And just for your interest, this is a picture of one of the oldest engineered structures of a fish trap, which is in northern New South Wales, which is thought to be 20,000 years old, many years older than the pyramids in Egypt. But today I do want to use this as an opportunity to talk about quantum technologies from an Australian perspective, but also letting you know that I have actually a deep personal interest, even though I'm Australia's chief scientist. I've actually had, counting it up, it's beginning to be a long career as a quantum physicist working in superconducting electronics, and turning quantum sensor technology into things that are market able to be used. And most recently, I led the quantum roadmap out of CSIRO on behalf of the quantum community. And my intention is to progress this in my time as Australia's chief scientist. So since starting this role, I have been speaking with many quantum stakeholders, both domestic and international. That includes government, industry, academia, and the academia includes universities and publicly funded agencies. And I've been talking to Australia's states and territories that have strengths across different parts of the quantum area. And I've found that each state actually has different focus areas that cover many parts of the quantum supply chain. There's a sense of ambition from the research sector and the industry to build and consolidate Australia's quantum ecosystem. There is a fundamental agreement across all the stakeholders so far to have a coordinated quantum sector in Australia, bringing together industry and research. And I'm hoping that you will see today that we've got strong foundations for this potential to be contributing to the global thriving quantum industry. This has been recently identified by government as in the digital economy strategy, and quantum was actually highlighted by the Australian government as one of the handful of key technologies that's shaping for Australia's future. So I want to use this keynote to outline where we've come from and where we're going, and taking up the breakthroughs that are happening in our labs here in collaboration with you overseas and in the US and many other countries, and use this to create prosperity and competency in all our societies. And I hope it will encourage you to see that Australia is keen to be a partner and collaborate and be part of the global quantum ecosystem. But first, I need to remind you that Australia may be a big island continent, but we're small, about 1/3 of the world's population. And we, though, account for about 4% of global research. So we might seem like also that we're a long way from everywhere, but you can see that the centre of the economic activity is actually moving closer to us as we're close to Asia, we're in the same time zone, and so we're hopeful that this will give us some ability to really contribute into the global scene. Nevertheless, we also have a long history in quantum devices and systems research. So, for example, CSIRO, which is where I used to work, the Commonwealth Government Research Agency, has been starting to work in superconducting devices in the 1960s. There, I guess, could be considered as macroscopic quantum devices. And in the 1970s, did early work on the Josephson voltage standard with hundreds of devices on a chip. And of course, now NIST operates those as international standards, where there's many tens of thousands of junctions for a voltage standard. They invented the calculable capacitor and then used squids to make them more effective, and also worked on other superconducting devices, including bow tie antennas for radio astronomy, magnetoencephalography, and so on. And then in the 1990s, which is when I started working in superconducting devices, we worked on high TC or high temperature devices and created commercial systems, a foundry, and they continue today. Other parts across the research sector in Australia really came to the fore in the 2000s, with Bob Clark at University of New South Wales garnering the research community to set up and take on board the idea of the Kane quantum computer with a phosphorus in silicon technology, and secured the funding of the first Research Council Centre of Excellence, which has gone on to be refunded 2 times and seen the spin out of other centres of excellence such as Equus. And as a consequence, we've got a lot of, I think, exciting research underway that's put Australia in a really good place to contribute to this global approach to quantum technologies. And you can see here just a picture of Australia with some of the different, or all the different research teams that are underway. And on examining what each state has been undertaking, I found that each state actually had a primary expertise. So in Queensland, you can see trapping ion traps and sensors. In Western Australia, high-performance computing and looking at having a link in of the high-performance computing with a quantum accelerator. In South Australia, it's sensors and materials. In Victoria, it's simulators. In the Australian Capital Territory, it's sensing. In New South Wales, it's really a major hub where you've got silicon quantum computers, the range of sensors and metrology. And just recently, we've announced the Australian Quantum Terminal as a national focus and front door for a quantum in Australia, based around the central station in Sydney. So we've laid the foundation and we have the history. But from here on, I want to talk about a different approach, which we're cultivating as we speak. Having worked in this area for so long, I have this vision of a quantum sector where both industry and research are significant, organised and globally competitive. And just in the last 18 months, we've seen 4 reports coming out from Australia considering the quantum opportunity. And they've all had consistent themes: the need to maintain critical mass in the quantum research expertise and long-standing investment, the opportunity to capture our market, and the need for a coordinated national approach. And the interest of government is highlighted, and as many of you will be aware, quantum technologies are specifically highlighted as one of 3 focus technologies recently announced in the global partnership between Australia, UK and USA, called AUKUS. And quantum is certainly holding the attention of our senior people in Australian government. I'm also working closely with the Chief Defence Scientist, Professor Tanya Munro, on Australia's approach to quantum technology. Australia is looking to coordinate and collaborate with like-minded partners to develop quantum technologies for defence and national security applications, which is often a spearhead to get things underway. You know about their star shots already, which are going well, looking at sensor systems, but also they're looking to harness and shape the strengths that are possible with allies, and also to be able to see how far they can go, bringing and considering how quantum computing can actually assist their plans. They held a 2-day quantum computing focus forum a couple of weeks ago, and I'm confident we'll see increasing opportunities to collaborate, accelerate, and to develop the applications and leverage all this to come together. One of the things that was listed there was a quantum roadmap, which I worked on when I was in CSIRO, and it identified the opportunity both in review and in the jobs, including an economic model. And it outlined pathways to develop an Australian quantum industry. With the Australian sector, public funded agencies and Australian Research Council funded centres of excellence, all driving contributions to Australia's quantum outcomes across different discipline areas, we know that we've got world-class and competitive technologies and capabilities. But now we're progressing to building the Australian quantum ecosystem. And our efforts are to recognise that quantum is more than just quantum computers. It actually requires all these different things listed here, from the materials and metrology. And also it's really interesting to see an interest in quantum biology emerging. To realise this potential, we're building the bridges between the different parts of the sector, along with areas of expertise pulling together and understanding that we are within a global paradigm. We're also seeing a concerted and coordinated pull to bring the full spectrum of stakeholders from research, industry, governments and startups coming together so that we are coordinated. Research and its translation requires a whole of ecosystem approach, and it needs true co-design and development between both federal and state governments and industry and researchers. Remembering, success will not be defined by the actions of just one institution, one state or one person, but it's going to require a collective effort and collaboration from a strong network. And this is where the potential is to really build on that and make improvements. So from this national approach, we've identified that Australia has got some end-to-end unique quantum industry solutions from our domestic industry, linking up with our international partners. We've got the foundational infrastructure standards, working on metrology, cloud, sensors. And we've also got the hardware supply chain, raw materials, working on the materials in processing, device fabrication foundries, implantation, the packaging, systems integration. And again, to deliver on that, we require drawing on global supply chains. And we've also got software expertise, error corrections, software algorithms underway. And collectively, we have a strong international engagement that puts building and inputs building on this global expertise. What we're seeing also is many quantum businesses that put Australia in a good position to capture some of that market, which Doug talked about before. As you can see, there are many companies beginning to emerge out of Australia. And this is what was identified in 2020 when I put that roadmap together, such as Quintessence, looking at cyber solutions, or silicon quantum computing, having a silicon, phosphorus in silicon computing technology, or looking at quantum tech for medical imaging with Lucigen, or precision timing with cryoclock, or Q control with error correction, or quantum brilliance, looking at having an accelerator on classical computers. In the roadmap, there were 14 quantum-related businesses worth about 120 million. But I went up counting yesterday how many have come since there. In just 12 months, we've seen that I was able to count up 25 companies in Australia working on quantum. And I know that there are also several about to launch. So it's something which is really exciting to see. And we know that they're attracting good amounts of capital investments, such as just announced in the last little while from Quintessence Labs, Quantum Brilliance. And on the back of this work, it's really nice to see Q Control last year being identified as one of the top startups listed in the world, which is really encouraging to see that the businesses that we're creating here are able to compete globally. However, it's more than just a good idea and a breakthrough with a research paper to get a product into market. And this is something which I think we need to understand, particularly those of us in the research sector. And that is that we need to have science plus. And this is science plus the engineering, science plus the user face and user face and system design. We need to have the right business model. And this is particularly important because if you look at major technologies that have really had an impact, from whether it's mobile phones, Amazon, iTunes, they've all actually changed the business model as well as the actual technology. You need to make sure you have the right governance and policy. And we need to also have the social license to make sure that anything we do is able to be accepted by the broader community. Of course, we need the classic marketing and all the things that go around trying to get a business up. So one of the early groups, or one of the things you've heard about a lot today has been the importance of creating a skilled workforce. And one of the early groups that have undertaken that is in 2019 was the Sydney Quantum Academy. And it's bringing together researchers, government, public funded research agencies, students, and major industry players within the Sydney Basin. And it's somewhat analogous to the Chicago Exchange. And they're just a start. We also have a master's course or various courses, for example, this master's course at Melbourne University, where you don't need to be a quantum physicist to be able to engage. We've seen the emergence of pulling together a wide range of groups such as the ARC Centre of Excellence for Engineered Quantum Systems, or EQUIS, and they had a hackathon just in August this year. It was focused on raising awareness of quantum computing and quantum technologies with potential end users, both in government as well as in industry, and prompting our next generation of innovators to undertake the application of discovery and validation and learn how to take things through to consider creating a business. And then, of course, here in Australia, we're starting our next wave of Researchers Young with Quantum Physics for Babies, which has been a real hit. So with a growing industry, what do we want to do with it? Well, we've heard a lot about this already, and I won't go into the details because this has been something which we've been focusing on today. But when I did the roadmap, we were looking at the potential to accelerate drug and materials development. We've also seen the potential for enhanced national security and support defence, increasing mineral exploration and water resource management for mining and other sectors, and improve secure communications, including in space. But one of the things which we absolutely missed in the roadmap, and is really interesting to see, and we've heard a bit about already today, is the impact it's going to have on quantum computing is going to have particularly on financial services, from credit scoring, derivative pricing, or financial procedures that involve many mathematical calculations. They'll become more complicated and resource intensive as the number of variables increase. So currently, calculations that land at less than optimal solutions will be able to be improved by being able to use a quantum computer. And the sort of application that is the accurate simulation of markets and the ability to predict how to change a commodity price will influence the cost of other assets, and using Monte Carlo simulations to forecast future markets and predict the price of options or assess the risk and uncertainty in financial models using quantum computing will be a real game changer. Of course, the other area is logistics. And we just heard from Doug before, this is one of the most valuable applications of quantum computing. It's in the supply chain logistics, scheduling, planning, routing, or routing, and the traffic simulations. And these are intractable problems that I think are going to be really worthwhile. And then, of course, when we go back looking at the big challenges, and it was interesting to hear Doug mention that what will really make things accelerate is by having a challenge approach to say, can we use a quantum computer or quantum technologies to really address some of the big issues here, which we face globally, from whether it's understanding climate change better so that we are able to model it. At the moment, we have got constraints, through to designing new plastics that are able to operate and not create so much waste, logistics of food security, and we've even seen with the COVID pandemic the design of drugs more quickly. And in each case, this means that we aren't able to solve many of these problems because they're intractable, and we can't do the sums exactly. And when we make approximations, they lead to us not being able to give absolute answers. So what do we do then? In each case, it requires us, when we have a vision or have a challenge, is to have a vision. But we need to know what are the science questions that need to be answered. We need to have the right people to be involved. We need to make sure we have the cutting edge equipment to be able to turn the ideas into practical and doable experiments and technologies. We need to do this with the collaborations both locally and globally. We need to have government support to really identify the challenge and put the funds behind it to see it come through. And of course, this brings together academia, public funded research agency, researchers, as well as industry. And again, I think that, I can't help but say, is quantum going to be the magic ingredient that's going to solve all these problems? So to wrap up, I think that we've, in Australia, we're on our way to have the full stack quantum ecosystem. We're on our way with a coordinated national approach. We're building on our long history of research. We're working hard to build that skilled workforce and building on the focus of Sydney Quantum Academy and all the effort that's going around all the different universities, and also the vocational education training centres We're working on and have a full supply chain from materials right through to product. And we're really keen that we're part of the global ecosystem. So with that, I just want to point out that next year in February, we're having a delayed Quantum Australia event. It's a conference and a careers fair, and I'd like to invite you all there. It's being run by the Sydney Quantum Academy in Sydney, and hopefully in February things will be open and easy to travel, or maybe not so easy, but less of a hassle than it is now. And I just want to thank you for this chance to share the Australian perspective of where we're up to in quantum technologies. Thanks very much.
Thank you very much, Dr. Foley, for giving us some insight into what's happening on the other side of the world. Do we have questions from the audience here?
Thank you for the wonderful talk. I had a question, right? From a government perspective, has quantum changed the policy approach at all, or has it changed the policy approach in fundamental ways?
That's a really good question. I actually think it's, let's go back a bit. The first thing is, in Australia anyway, what the Australian government has done is it's actually having a strategy of a digital economy. And that's the first step. And it's got an aspiration to use digital capabilities to really give an accelerator and boost to the Australian economy. And with that, of course, comes new technologies. And so what we're seeing is that the Australian government sees the role of quantum, and it's identified this in the strategies that it's put forward. And it's on a pathway to really see how this will make a difference. It hasn't, if you look in the defence area, it's of course one where I think most defence departments around the world are recognising that it's got a lot of power and potential to add to its cachet of security measures. But when we're coming down into sort of the more everyday part of government, I am only at the early stages of working my way through, talking to our elected parliamentarians to show the potential of what quantum has to offer. And every time I speak to any one of them, they are very excited and are very keen to see this come to fruition. Particularly the areas of logistics, optimization are the ones that they see are going to be really of great value. And then, of course, secure communication is very much a critical area too. So that's where it's up to. I think it's at the initial stages, and it's one where it's part of my role, and I guess it's part of the role of all researchers and quantum technologists, is to be able to explain where it can make a difference and how it can really support, whether it's a business or a government, in being able to deliver better to whatever their strategy is and what their reason for being is.
Hi, thank you so much for your talk. As I think a lot of people know, Australia has been an international leader in quantum information science, and wondering what people are thinking in terms of the Australian national strategy as technology continues to develop. We've seen Australia does a lot of things well. There's starting to be conversations about how to maintain that sort of leadership role, starting to focus on some of the things that are sort of taking shape faster, or is it still early on and people are kind of hedging, looking at multiple spaces in the quantum development sector?
Yeah, so that's a good question. So since I've been in this role, I've been asked to champion the quantum effort in Australia to to bring it all together and to create that coordination. In the time, it's 11 months since I've been in this role, I've seen very significant progress. So the first is identifying, which I said early on in my talk, was the recognition that each of the states and territories in Australia that have quantum research actually have a real focus area of their primary area. And then the next is also looking at, as you mentioned, what are the different parts and how they fit together, and the realisation that there's lots of the parts of the supply chain that exist already. And the thing is also interesting is going back even further into the supply chain looking at the fundamental materials, because Australia has a lot of mineral deposits, and we're very good at providing the mineral deposits as materials for around the world, but we haven't done as much materials processing as we should do. So we're working on that. And then working the way up through looking at how we can make sure that we are supporting as necessary, and also creating the challenges and the focus areas. And that's emergent at the moment, and I think we'll see more coming about that in the near term.
Okay, I know that we have a couple online, so why don't we go to those?
All right, so a question about quantum workforce in Australia. Since you have a small population overall in Australia, 26 million, Illinois has 12 million people, so half. New York State has about...
Shanghai has the whole of Australia's population in one city. I get that.
Yeah. So what strategies will you employ to develop the required quantum-skilled workforce for moving forward?
Yeah, so I think this is a huge global issue, and that is how to build up. So the first thing is going through looking at what are the skills audit that is needed. What are the different skills you need? And also recognizing many of them are quite transferable, so that we've got a whole range of new industries being developed in Australia, from whether it's a hydrogen economy to replace our current fossil fuel part of the economy with hydrogen as sort of low emissions energy source which we can export, through to space and machine learning, artificial intelligence. If we add up the number of jobs that are needed for all these areas, and you add quantum on top of that, which we've estimated to require about 16,000 roles or jobs in Australia, then when you start looking at where do they come from and where do we have to bring them into the system, one of the things that's really critical is going right back to school and making sure that young people at school today understand, and we're very lucky in Australia. We have an excellent education system. We have the ability of young people to go, regardless of where they're growing up, to be able to go to tertiary education. And what we have to make sure is that they understand that there's the career pathways. And I think that's something which is always quite tricky, because most people know what a doctor does, what a lawyer does. That particularly there in high schools in Australia, they often think if I get the top mark at school, even though I might be best at maths and science, I'm going to be a lawyer or a doctor. And we all know that they're probably skills or professions that will be majorly impacted by AI and machine learning. And so I'm sort of saying we need to make sure that they understand that there's you can do STEM-related subjects in high school and at school, and that you can have not just a job working in a laboratory in a university, which is quite narrow and very few people end up there, but there's a whole range of jobs in industry, in government, and also public funded agencies, so that we're sort of widening that viewpoint. So that's the first thing, is getting the flow up, and then the other is making sure that we've got because we're a demand-driven education system, that creates a demand, but also then making sure that the tertiary courses are lined up to where the industry opportunities are, so that although you want to make sure people are educated and not just trained, because we need to educate people to be able to transfer between different areas, because in a lifetime, any one person will have a range of different careers. And we need to make sure that we're providing the education plus the ability to line that up. And then, of course, there's whose role is it to do that specialist training? And this is something which defence departments do very well, but also looking at those micro-credentialing, the extra courses such as diplomas and master's degrees that really allow people to focus on that. And, of course, then there's also the self-education, some of the things that are happening on the cloud with, like Q-Control, IBM, and so on, have got the ability to go in and learn as well, so about how to lift those skills. So it's bringing it all together, making sure you've got clear indication that there's an opportunity there, and then getting the young people coming in seeing this as an opportunity for them. But when you think about the scale, there's a lot of work to do to make that come together.
Great, thank you. I think we have time for one more quick question.
Okay, we have one more from our virtual audience. Hopefully this is somebody in Sydney, because they can probably use this advice. What's the current state of venture capitalist potential funding of Australia's quantum startup groups, companies?
So, so venture capital in Australia has not been a strong thing in the past, but since about 2016, we've seen a real lift up in that. And one of the biggest issues for many of the venture capitalists who wanted to invest in quantum was actually finding something that was investable. And one of the things that was set up by the Australian government with the CSIRO using a range of different sources of funding was setting up Main Sequence Ventures. And that was an interesting venture capital company because what it's done is it's starting to invest in lower technology readiness levels. Quite often venture capital wants to come in quite high and Main Sequence Ventures is coming in much lower. So this is at the moment, I think they've invested in 3 quantum startups and they're looking for more. So that's an example. They've just done another capital raising and they've been very successful. In fact, they were oversubscribed with the raising. So what we're seeing is that interest. We also, I guess another thing is looking at investors from, for example, the areas of our superannuation. Australia has a very strong program of people paying into superannuation and those funds got lots of investable money. At the moment, though, we haven't got it lined up as well as possible to see how they can invest in or set themselves up to invest through some intermediary. So there's work to be done, but there's the recognition that there's the opportunity there. And I think as we get this coordination that's underway recognised, it will give confidence because, with any investment, it's all about the risk and it's all about making sure that the governance is there and that the investment is something that's able to be managed. So we're in that process of bringing it together, and it's and the early indicators are showing that that things are beginning to improve, and we're beginning to see that investment of venture capital into some of the startups coming out of Australia.
Great, thank you so much. Let us thank Dr. Foley again.